the AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Hello, everyone. Good morning, good afternoon, good evening from me as well. I'm Guilherme Martinez Roura from the International Telecommunication Union, and I would like to welcome you all for joining today's AI for Good webinar on MathDance hands-on workshop to learn math, coding, and AI, organized by the ITU in partnership with the Lawrence Technological University. This special hands-on workshop is part of the AI for Good youth programming track designed to provide young learners with practical skills in mathematics, coding, robotics, and artificial intelligence. By engaging with AI and coding in a creative and interactive way, participants will be better equipped to understand and shape the role of AI in solving global challenges. Without further ado, I would like to introduce our presenter today. His name is CJ Chung, and he is the professor of computer science and director of CS and AI Robotics Lab at the Lawrence Technological University. CJ, welcome, and the floor is yours.
Thank you, Glenn. Thank you so much for having this opportunity, providing this opportunity. And I would like to share my screen. Hello, everyone. I would like to introduce AI machine learning, deep learning with teachable machine and Scratch for teachers, parents, and young people. I'd like to thank United Nations, ITU, and AI for Good to provide this opportunity to present this workshop. My name is CJ Chung, Professor of Computer Science, founder of Robotics, and Director of the CAR, Computer Science AI Robotics Lab here at Lawrence Tech University, Southfield, Michigan, USA. To find more about my research projects, please visit this Wikipedia page. Goals of MathDance workshops are to learn basic concepts of machine learning and deep learning, learn and sharpening Scratch programming skills, learn mathematical functions, to learn and integrate math, AI, and Scratch to develop a MathDance game app, and advance the quality of education, which is one of the UN's SDG goals. This presentation file in PDF is available in Resources tab. You can also download the file at the URL shown here. So please take a moment to download the presentation file because it's a hands-on workshop. You may need to see, the PDF files. At this time, I'd like to introduce our assistants for this workshop. They will answer your chat questions. So if you have technical questions, please use the chat function to ask questions. First, Dr. Gwang-Chung Ju. Hello, Dr. Ju. Can you introduce
Hello.
yourself?
Hi. Well, thank you, CJ. Welcome, everyone. My name is Guangchong Zhu. I'm a math professor. Also, like CJ, I'm teaching at the University of Lawrence Technological University. Thank you.
Thank you, Dr. Zhu. Julius?
Hello, everyone. My name is Jerry Cesar. I'm a dual enrollment student at Lawrence Technological University. I'm a participant in their RoboFest competition, and I also did research over the summer there with Dr. Chung.
Thank you, Julius. Hi, Gregory.
Hello. I'm a student interested in computer science, and at LTU, I have done research under Dr. Chung. Thank you.
Thank you, Gregory. It is recommended to use full screen mode because a lot of technical things are covered on the screen. So please scroll down and click on the screen mode button. Yes, I would like to introduce first the concept of machine learning. What is machine learning? Machine learning is a subfield of AI. We can define AI as to mimic the intelligence of humans. Then what's machine learning? As you see, ML is a subfield of AI that makes machines learn from example data. Data can be labeled, unlabeled, or past experience. Then what's deep learning? Deep learning makes machines learn from example data using brain-inspired algorithms. Today, we will use only labeled sample data using supervised learning method, which is the most popular learning method. Okay, you see lots of cat images. You see lots of dog images. They are all labeled. What's the label of this image? So we know our brains were trained to recognize this image. This is a dog. This slide summarizes the concept of machine learning. we have two classes, cat class, dog class. In the cat class, there are many images of cats. In dog class, we have images of dogs. We use those images to train this artificial brain. After the training, if we show an unseen image like this trained model can label this image as a dog. Another example. Something is wrong here. Can you find the error? Yes, correct. You know, by human error, they are labeled as dogs. Dogs are labeled as cats. If you use this wrong data set, when this unseen image is presented to the model, the answer can be wrong, cat, because of the human error. How about this case? Can you find an error here? Yeah, this cat should not be here in this dog class. So if you train with this wrong, data set, the training may not be so good. The trained model may produce some errors. Another example, you see some normal chest X-ray images here. Those are normal cases. Those are COVID-19 chest X-rays. Those are pneumonia case. Can you answer what this X-ray is? Since we are not medically trained, we don't know the answer. So, yeah, let's train a deep learning model. So, using many X-ray images for normal cases, we train. Also, we use COVID-19 images. We train also with pneumonia images. We train the deep learning. After the training is done, if we present this unseen image, yes, this will answer normal, which is correct. This is a normal case, X-ray of normal case. Today, what we'll be doing is to introduce 5 classes of hand gestures that represent mathematical equation graphs. We use the tool Teachable machine to train a deep learning model. Then we write Scratch code to connect to the trained model on the cloud, and we code to send current webcam images, and we program Scratch to get the results from the trained model. When we send unlabeled image such as this, which means y equal to x, trained model will return with the label of this hand gesture as well as the confidence level in percent. we say this step, to send unlabeled data and getting the answer is as inference step. Before we begin, I'll just show you our goal today. So, yeah, this is a YouTube video. You can find the YouTube video here, and you will, you will watch what you are going to do today. This shows the current label as well as the confidence level of this recognition. Right.
Ready. You have 5 seconds for each question. Show me y equals 10x. Good job. Show me y equals x. Good job. Show me y equals x. Good job. Show me y equals x. Good job. Show me y equals 10x. Good job. Show me y equals minus x. Good job. Show me y equals minus x. Good job. Show me y equals 0. Good job. Goodbye.
Oh, I'll just check. Did you hear the sound? Okay, it seems you did. Right, thank you. Now, to develop that app, I would like to first introduce Google's Teachable machine. I want you to actually roll up your sleeves to make a gesture representing y equal to x. This way, y equal to minus x. This pose is y equal to 0. This pose is y equal to 10x. The slope is very steep. So I want you to create 5 classes of images. Today I'm choosing only, the mathematical graph that can be used only one hand. So y equal to 0, y equal to x, y equal to minus x, y equal to 10x, and a special case, none. For each class, I want you to collect around 50 samples, then train, and if you show a new image, this trained model will output the correct label. In this case, y equal to 10x. To do that, we are using 2 tools. First, Teachable machine, which is using a pre-trained model called mobile lab. The other tool you need to use is machine learning for kids at that URL. So you have the PDF file so that you can click on this, or you can just use Google search Teachable machine, then you'll find the link, machine learning for kids, then you'll find this link. Okay, so you need to go through these steps. So let's first train a model for 4 hand poses. So you need to go. So I'll do a live demonstration, but just watch what we'll be doing. So go to that Teachable machine site, click on Get Started, new project, select image project, and select standard image project. Then you are supposed to create 5 classes. I'll demonstrate sooner or later. And for each class, like 0x, -x, 10x, none, then click on training. Then after the training, and during the training, you'll find more details about how that deep learning model can be trained. After that, I want you to test, then save the project file. This is task 1, and I'll demonstrate from the beginning. So go to Teachable machine. So if you cannot find, I recommend you to type Teachable machine. Then you'll find, the link for the Teachable machine. Then click on Get Started. Click on Image Project, Standard Image Model. Then you'll see this interface. Class 1 as 0. Click on Webcam. And in this case, I don't see, the image because I forgot to turn off my camera. My camera is held by the Zoom, so I need to, I need to turn off my camera. So then I will, yes, in this case, I think I can reload. Yes, now I see my image through the webcam, and the class 1, 0, then hold this button to record a sample or sample images. So 0 is like that. Then you can collect images representing y equal to 0. I recommend you to collect around 50 images for each class. Bar close. Then see, I made a mistake when I clicked this button when I without showing my hand. So something like that, we need to actually delete. So I made one mistake when I clicked somewhere. Okay, I think everything's okay. Oh, here. See, 2 images did not show y equal to 0 pose. So I'll delete, and I'll also delete that. Okay, let's double check. All the images are correct. Okay, now y equal to x. Click on webcam. So y equal to x like this. Hold further, closer. Take around 50 images. Then go through whether there are wrong images collected. Okay. Looks every image is okay. The next class is -x. I recommend you to type -x instead of -x because our Scratch app will read this -x. All right, so like that, hold All right, and verify if every wrong image was captured. Looks okay. Add another class, this time 10x. I recommend one blank between 10 and x because our Scratch app will be reading, this text string. Show a vertical pose. Then collect around 50 images. Okay, then the last one would be none. So don't show your hand, just your face. I'll take some pictures with my sunglass because, AI is smart. This deep learning model is smart. It can detect me with glasses, without glasses. Okay, so now we collected the image without my hand. All right, time to train. So click on this train model button to train. It will take around 20 seconds. Now a deep learning model has been trained. Then you can test how, your trained model by showing your hand. So currently I did not show any hand, so it says output is none. If I show y equal to 0, yes, 100% recognized. About y equal to x, yes, almost 100% recognized. About minus x, 100%. About 10x, yes, 99% recognized. I think, yes, it's well trained. Now, I want you to learn about how to save your project file, Teachable Motion project file. Before you do that, I want you to turn off your webcam. So make sure you turn off. So your webcam is the input and input is turned off. Then I want you to save your project file as, so click on these three bars, click on download project as file. And I have a special folder to store all the Teachable Motion files. I'll type as MathDance 1 and save. So I trained yesterday, but I just overwrite. Okay, so this is the task 1. So I'll give you a few minutes to complete this task 1. If you complete this task 1, can you use the chat to say that you completed task 1? And again, you can download this workshop material from Neural Labs resources, or I gave you the link in the beginning. So yes, the link is here, robofest.net/dl/mathDance1 un.pdf file. Okay, since I gave you the slide file for this presentation, yes, you can follow all the steps, exactly what I did. So I would like to continue. To save the TM project file, click on 3 bars, then you can save on Google Drive, or you can download as a file and you can store the file on your computer. Also, make sure to turn off the camera because we are using the camera for the Scratch app. And it's good to practice from the beginning. That's why I want you to close the web browser. Now, time to introduce Scratch coding. I know many of you already have Scratch experience, but I heard some of you don't have any Scratch experience. So I would like to briefly introduce Scratch coding. Why Scratch coding? Scratch programming is great tool for use for the following reasons. It's easy. It supports multimedia. You can learn programming concepts, computer science concepts. You can improve problem-solving skills. Scratch coding promotes creativity, expression, and imagination. I like Scratch a lot because it provides the means to do cross-curricular activities by integrating math, science, art, robotics, AI, storytelling, even physical activities. Okay, so Scratch coding is quite intuitive. Actually, you do not type text, you draw the program by drag and drop. So you may guess what this program is doing. So when the flag is clicked, you repeat, and the number of repeats can be chosen at random between 1 and 3 inclusively. Then this will speak alone. So if you run this program, you will hear 1 hello or 2 hellos or 3 hellos. It depends on the random number chosen, right? So yes, let's test this simple code using machine learning for kids using your browser. You don't need to download any app. You can just use your web browser. So go to machine learning for kids.co.uk and click on get started and click on text to speech extension. Then let's create this first program. So I'll demonstrate. So please watch what I do. Okay, so I'll close this teachable machine, and to find this site, just type machine learning for kids. Then you'll find machine learning for kids. But I want you to use these pre-trained models. Then you'll see get started. By the way, so MIT Scratch site, you can write simple code without AI. But if you come here, then you can write the Scratch code using pre-trained models. So I would like first, practice and learn some basic Scratch, which is directly related to the app you are going to develop today. So if you click Get Started, you will see this Scratch palette, block palette, and workspace or canvas, then stage and sprite. Here we don't use this cat sprite. That means we are directly writing code for the backdrop here. I'll make it slightly smaller. Then click on event. Then you'll find this block to start the program. Then I want you to click on control, find, repeat a number. But we are not repeating 10 times. The number is decided by a random number. Random number block can be found in operators in green color. Select pick random. And according to sample program, I was choosing a random number 1 through 3. Then I want this code to speak to you. To do that, we need an extension. Click on this and choose text-to-speech extension. Then you'll find speak hello, move it to there. Then, yes, this is the first program. How to run? Click on this.
Hello.
Did you hear one hello?
Hello. Hello. Hello.
This time 3 was chosen, so you heard 3 times.
Hello. Hello.
This time 2 was chosen, 2 hellos.
Hello.
Oh, this time 1 hello. So this is the first program for you to test, and this exactly same program will be used for today's final program. I guess everyone completed this. Again, if not, yes, please take your time to follow my PowerPoint slides to exercise, simple Scratch programs. Okay, now let's go back to our slide. So we completed task 2. Now I would like to introduce Scratch variables. A variable can hold either a number or a string. So to create a variable, you need to click on this orange variables, then click on make a variable, then you need to enter the name of the variable you want to create. And this program will be selecting a random number between 1 and 6, and the number will be stored in a variable called number. Then this block will say the number chosen. All right, let's practice that. Okay, so what I'll do would be I'll make it slightly bigger. Yes. All right, so okay, so when green flag is clicked, I want you to get a random number between 1 and 6 and store into a variable called number. That means we need to create a variable. To create a variable, click on these orange variables, make a variable, and number. Enter number. Then you will see this set my variable to 0. Drag and drop there. Not my variable, select number and pick random from 1 to 6 like a die. Then let it take hello. Not hello, but speak the number chosen by this random function. So speak number instead of text. And remove this here. Okay, let's test.
2,
The first number chosen was 2.
4.
Now 4. You can click here too.
1,
1,
1,
1,
4,
4,
2.
2. Yes. So you learned about how to use the random, how to generate a random number, and you learned how to store the number into a variable called here in this case number. Okay, so task 3 is done. Brief introduction to machine learning for kids Scratch project editor. This side is called Black Palette. Here, this is the canvas. You draw the program called coding workspace. Stage. So, we will show camera images on this stage, but we don't use a sprite on the stage. And we are writing code for this backdrop 1. Also, I recommend you to type your project name here when you save your Scratch code. This file name, this project file name is used. You may make it smallest stage, medium size stage, and you can make maximum size stage view. There are 6 Scratch block shapes, add blocks, such as the one with a green flag, stack blocks, perform commands, and this hexagon shape, Boolean blocks are the conditions. They are either true or false. C blocks for loops or conditional if statement. This is a report block that can have a number or a string. There are many Scratch blocks grouped in categories. Today, we'll be using sound block category, events, control, sensing, operators, variables, my blocks, and images. Also, we need to create a list. To create a list, click on variables, click on make a list, name the list. We are going to create a list named shopping cart that can have multiple items. So also you need to learn how to create your own block, so-called my block, to define my shopping, for example. To create my block, click on my blocks, click on make a block, and name your block, for example, shopping. Okay, then this will appear on your workspace. To define my block shopping, first, I'd like to delete all of the shopping cart. I'd like to clean up the shopping cart, nothing inside, make sure, then add your, your things to buy. So like add orange to shopping cart, add apple, add egg to shopping cart. Yes, this task 4 is to practice the use of my block and list. When green flag is clicked, called shopping, which is defined as a my block shopping. So shopping means clean up the shopping cart, add, in this case, three things to buy. Then you can, speak the length of shopping carts. That means, how many items in the shopping cart. Then find out the number 3 item you purchased from the shopping cart. Okay, so this is task we are going to practice. So open this Scratch. Then I would like to first define my block. But before doing that, I would like to create a list. So name the list shopping cart. Okay. Then I would like to create my block. Click on make a block and shopping. Say okay. Then you see, the head of the my block. Then what I would do would be first clean up the shopping cart. So if you go down, shopping cart list is defined here. Select delete all of shopping cart. Drag and drop, delete all of shopping cart. Clean up the shopping cart. Then I'd like to add things to the shopping cart. So add things such as apple. Then point this block and right click, then you can duplicate. Orange, the same thing. Duplicate egg. ORANGE. Okay, now to use this shopping my block,
3,
can go to my blocks, then you'll find shopping, which means deleting and adding 3 items. Then I would like to know how many items in the shopping cart. To know that, click on variables. Under list, you'll find length of shopping cart. Okay, so yeah, let's run this code. So click on that.
3,
Did you hear 3? Because we have 3 items.
3,
Then let's access the last one we purchased. So to do that, we need another speed.
3, 3,
Then click on item 1, first item from the shopping cart. But I would like to know the third one. So if we run this, you will hear 3 and the third item, which is the egg. So
3, egg,
So yes, it says 3 egg as we expected. How about the first item we purchased? That means 1.
3, apple,
What happens if I say 5? We didn't, there's no, 5th item in the shopping cart. In that case,
3,
Scratch ignores because nothing there, so it doesn't say anything. Okay, so we completed task number 4. Now, important concept, repeat until. So we'll be using repeat until block, in our final project today. So please, understand about this important repeat until block. It specifies, to repeat, termination condition. So it will repeat repeat until this Boolean termination condition is met. Okay, so this is a program to test as task number 5. How many hellos can you hear if you run this? So it has a variable counter set to 0. It will repeat the body of this repeat block until this condition is met. If this condition is met, no repeat, end of the repeat, that means end of the program. So yeah, let's think about number of hellos you can get from this code. Okay, by the way, this hexagon shape in green color is called a Boolean block. It can be either true or false. If false, termination condition is not met, that means to the body. If this becomes true, end of the repeat. Okay? Okay, anyway, when the program starts, counter is set to 0 and check whether the counter is greater than 2. In the beginning, counter was 0. Definitely 0 is greater than 2. No, that means to the body, speak hello. So you will hear one hello. Then the counter is increased by 1. To decrease, you use -1. So this is plus, so the counter becomes 1. Then check again the termination condition. If the counter is counter is now 1, 1 is still not greater than 2. So this is false, not true. Not then to the body. So you will hear another hello. Then counter becomes 2. Is 2 greater than 2? Still no. 2 is equal to 2, not greater than 2. So you will hear another hello. Then counter becomes 3. 3 is greater than 2. That means the termination condition is met. End of the loop, end of the program. So if you run this code, you will hear 1, 2, 3 hellos. Okay, so I want you to practice this task number 5. So I'll demonstrate. So we don't need shopping here. We don't need we don't need that. We don't need that. Okay. Okay, so we need to create a new variable called counter. So click on make a variable, type counter, then set the counter to 0. Then we need repeat until block. It's under control. So repeat, not a number, go down, then you'll find repeat until the Boolean block. Okay. Then we need to specify the termination condition of this repeat. To do that, we need the block in green operators. You'll find greater than, move it to there. Then we will be using the counter we just created. And according to sample program, you're using number 2. Then if not met, we are going to speak hello. So the speak can be found here, text to speech. Then we need to increment the counter by 1. So variables and change counter by 1. All right, let's run this code.
Hello, hello, hello.
Okay, let's rerun.
Hello, hello, hello.
How many hellos did you hear? Let's rerun
Hello, hello, hello.
3 times. It goes 0, hello, 1, counter is 1, hello, counter is 2, hello, counter becomes 3, true, the termination condition is met, end of the repeat, end of the code. Okay, now let's go to so we complete task 5. The next one is about having a stretch break. Okay, this animation is one of the things you will be doing on day 2. It's a simple picky math dance animation to synchronize, the music and the pictures. We are using Scratch broadcasting mechanism. Anyway, let's watch. Okay, this is what we'll be doing. Day 2. And let's have 3-minute break. And at this time, I want you to actually complete some Scratch coding if you haven't completed yet. And so we will be having 3-minute break. Before continuing this workshop, I'll play the Picky Math Dance video again. See you soon. Okay, we'll begin soon after this stretch break with mathematical dance. Okay, welcome back. I will introduce important concept called nested loop, nested repeat with repeat until. If you see this sample code, we have an outer repeat, repeating 2 times. Inside this repeat 2, we have another repeat until. Okay, let's find out how many vowels you can hear. Can you guess? So one difference is this number 3. It was 2 before, now it's 3. Can you guess how many vowels you can hear? Okay, so yeah, let's figure it out. But you can see when the counter is 0, 1 vowel, 1, 2, 3, starting from 0, so 4 vowels. Then counter becomes 4, end of the repeat until. But we have another outer repeat, so it uses the multiplication concept. 2 multiplied by 4 would be 8. So you will hear 8 vowels. Okay, let's actually find out whether you can hear 8 vowels. All right, so we need control, repeat 10, but we are testing only 2. Then we'll be using this code exactly as is. And I'd like to change this to 3, right? Okay, let's test it.
Hello, 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 hello,
Okay, let's test once more.
hello,
0, 2,
hello,
3,
hello,
4,
hello,
5,
hello,
6,
hello,
7,
hello,
8.
hello.
Yes, we heard 8 hellos. So yes, for the final program for today, yes, we are using this nested repeat. Okay, now I have a question for you. Can you read this code to see how many vowels you will hear? To read the code, we have repeat 2. Inside, we have repeat until counter is greater than 3. But one thing is different. We used set the counter as 0, but now the initial counter value is 3. Can you guess? So in this case, when counter is 3, 3 is greater than 3. No, it's equal to 3, not greater than. That means this repeat will speak wow once. Now counter becomes 4. Is 4 greater than 3? Yes. The termination condition is met. End of this repeat until, but we have another auto repeat. So the concept is to multiply by 1. So you will hear 2 vowels. Okay, task number 7. This is also an important task. If with logical AND operator. For this task, you need to create 2 new variables, one recognized as, the other certainty. So we first set recognized as a cat, certainty as 99%. Then we have a conditional if block, and we have a condition defined using logical AND operator. This will be checking whether recognized as is cat is true, and whether the certainty is greater than 80. If both are true, then it will play meow cat sound. All right, so yeah, let's write a code doing that. All right, so we don't need those. Okay. So we need to create two new variables. One is recognized as, the other is certainty. Then use set certainty. Oh no, actually first recognized as cat. Then duplicate certainty as 99%. So we are sure, the recognized image is a cat. Now introduce another control called if block. And we need a Boolean block. In this case, we try to introduce logical AND operation. So click on operators, you'll find Boolean block and another Boolean block. Move it there. Then we need to check whether recognized as is cat. Click on variables, recognized as, and we need another Boolean block, checking whether the certainty is greater than 80. So we will be using operators greater than, and so certainty is in the variable and 80. Okay, so if recognized as is cat and certainty is 80, both should be true, then yes, let's place cat sound. So click on sound and play sound until done. Oh, but it does not have cat sound. Oops. So to find the meow sound, click on this. Oh no, actually not that one. Sorry. Yep, click on, go up here, then you'll find the tab for sound. Oh yeah, you need to go up, 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 up. Okay, let me see. For some reason, my screen became here. Okay, so go up here. So we are using this code tab and click on this sound tab. It has only pop sound. To add meow sound, you need to go down. Just hover on this icon, then you'll find search, choose a sound, and click, type something like meow. So add this one. Then go back to code and you'll find meow. Let's run it. So yeah, we said recognized as cat, certainty as 99. That means this is true. 99 is greater than 80, so both are true. So you will hear meow sound. Okay, let's change the certainty as just 60. Can you hear those meow sound? No, I don't hear any. Let's make it to 81. You hear it. Okay, so that's task number 7. Right. So task number 7 is done. This is just a bonus. Actually, this, logical AND can be rewritten using nested if coding. So it's like one condition inside if you introduce another if, then the two programs are identical. But for our final program, we will be using logical AND. Another review question: what will you hear? So recognize as cow, certainty 78. Yes, this is true, but certainty 78 is not greater than 80. So this is false. True and false, because false, everything as a whole is not true. Then, if not true, then don't do the body. Don't do the if body. That means you will not hear the moo sound. Okay, the last agenda. So, yeah, let's combine everything we learned so far to create the hand MathDance game app. Okay, so we did this step before and we saved the project file. Will be actually open the existing project file from a file, then train, test again. This testing is important. And retrain if you change some images, then test again thoroughly. It's recommended to resave if any images were changed. Test again. Then now it's time to export your model to the cloud. Then upload, click on this upload my model button. It will take around 1 minute. Then you will see the web address, the internet address of your model. Copy the URL, and it is recommended to paste it, to save it to Notepad in case you need to, recreate the code later. Then again, I strongly recommend you to close the Teachable machine, also turn off the camera on TM, because your Scratch code needs to access the camera. After doing that, go to ML4K site, click on Open a TensorFlow model at the bottom, paste the URL copied in step number 7, and click on Open Scratch. Then you will see the Scratch canvas. When Scratch is open, first check if the right model is connected. So click on TM My Image Model. This shows that your code and the model is connected. But to double check whether every class has been exported, click on this report block. Then you will see 5 classes: 0, none, 10x, minus x, x. Then you need to import now 2 extensions. One is video sensing. The second is text-to-speech. Then remove the cat sprite because we are not writing code for this cat, then recommend to name the project file as MathDance1 here to save your scratch code file. Then create the following and test. So this is something, I want you to double check whether everything is okay. Be ready to start your code. Then save the code as mathDance1.sb3. Scratch files have this extension, sb3. Okay, so I'll demonstrate. So let me see. Okay, here. All right, so to do that, what we need to do is open machine learning for kids again. No, actually, we need to click on Teachable machine, get started. So now open an existing project from a file because we saved our files before. Then I saved it under TM and I saved it today, September 18th as MathDance1. So open. Yes, those are the images we collected. I'd like to actually add some more X. I still think X was not that good before. So I'll open and I'll verify whether all the X poses are okay. And I'll add just some more. Okay. Then let's retrain. Then let's test X. Yes, 100%. Minus X, 0, 10X, none. Yeah, looks like it's well trained. Okay, also I'll test with my sunglasses. Same problem, same performance. Great. Right, then time to export the model to the cloud. So click on this export model button. Then you'll see this interface. Just use the default setup. Don't click on anything, but here, upload my model. So click this. Yeah, it'll take around 30 to 1 minute to upload the trained deep learning model based on mobile lab. Okay, now you have your shareable link. This is the web address of your model. Copy. And I strongly recommend to use Notepad to save the URL. So I usually do this way. So this is the URL with 4 functions at my office. I'm at office on September 18th. Before. Okay, I saved it just in case. All right, then, okay, I click again just in case I lost. And close. Make sure to turn off your camera. And since I added another, images for my for X, I would download, save MathDance1 again. I will just overwrite. Okay, I saved all the project file, and also I saved the link, on the cloud. Time to close this teachable machine. I'll leave. Then open this machine learning for kid. Then not this one. You're not just testing simple scratch code. we are using the trained model. So go down, go down, go down, go down. At the bottom, you will find TensorFlow. So actually, the model was trained using TensorFlow. So click on Open a TensorFlow model. Then paste the URL you just did. Okay, let me complete once more. Okay, then click on Open Scratch. All right, if you do that, then you will see this one, my TM image. I mean, TM, Teachable Machine, my image. Click on that. On this report block, make sure it has all the classes, like 0, x minus x, 10x, none. Okay, seems like we are all set, but I recommend you to add a comment about this code. So what I would do would be, I'll put this one, all the information about the model as a comment. Paste, oops, it doesn't paste. Okay, so I copy, paste. Okay, so, and I just leave it. Oh, by the way, we are not writing the code for this scratch sprite, so delete. But before delete, because we have this, you may actually, you may put into this state, then delete. Then you will not lose. Oh, actually, I lost. Okay, so anyway, let's do once more, and I paste here. Okay. Then also, I would like to first test our camera. So video sensing, then make sure you see, this webcam image. Then what I would do would be testing the connection. I'll start, then I will always the camera connection is important. So what I do would be video sensing, turn on the video and set video transparency as 0. That means it will be clear. So let's see. Oh, okay. Now I would like to check the connection between Scratch code and the cloud model we trained. So to do that, I'll have wait until the connection is established. So wait until, click on this TM, it's the machine model, let's use. Then I'll say ready. So I'll add another one, speech to text. I'll speak, the model is ready. Okay, so yes, this is the beginning. If I run it,
The model is ready. The model is ready.
yes, that means it was waiting until the model is connected. If connected, it takes the model is ready. Okay, I think we are ready to write the final program for today. Okay, so before doing that, actually, I would like to test once more another simpler program to test about the inference. So what I would like to do is, after the model is ready, I would send webcam images and to get label and confidence number. To do that, we need two variables. So click on variables, make a variable. Let's create a variable called label. Also, another variable called confidence. Okay, so set confidence, actually set label, and we need to get, first we need to send the current webcam image to the cloud model. Then cloud model will send back the label and the confidence. To do that, yes, we need to click on TM, my image model, and click on recognize label. What this is doing is, this will ask to recognize the data, then cloud model will return the label, and the label will be stored into the local variable called label. So we need to send the current image. How do you send the current image? Click on images, then you'll find webcam image. So it's like recognize the current webcam image and send back the label. Then I will store this label to this variable label. And this label will be displayed on the stage. Okay, so this is for the label, but it sends also the confidence. To do that, we need another report block, recognize confidence, and send webcam image. But if you run this, it will run only once. So we have to keep repeating, recognizing every frame. So we do need another control called forever, and put it there. That means, yes, we'll be keep sending current webcam image to get the label of that and confidence of that image, webcam image, repeatedly forever. Okay, let's test this code.
The model is ready.
Now, current label is none, and confidence is 99%. Okay. Now, if I show y equal to 0, did you see? Do you see label 0, confidence 99.9 something? About 10x, 97, 98% confidence. About y equal to x, 99% confidence. About minus x. Yes, it says label is minus x, confidence is 99%. Okay, so I think all set to write the code we would like to develop today. All right, so let's go to, so anyway, what we have done is we already complete task 8, and this summary slide will, summarize all the steps, all the 16 steps. Now we tested this code to repeatedly show the current webcam images label as well as the confidence. Now the final task. However, always you may have some troubles of getting no webcam image on the stage. This happens because you have only one camera on most computers. So teachable machine might be holding your camera. For my case, in the beginning was Zoom. We are using Zoom app. Zoom was holding my camera. So to solve this problem, you could run video off, video on commands in Scratch. Sometimes it doesn't work. Method 2 would be, close the web browser and restart your Scratch code. Okay, anyway, so let's see again our final goal. This is what we are writing for today. So I'll replay the project for today.
Ready. You have 5 seconds for each question. Show me y equals 10x. Good job. Show me y equals x.
My reaction
Good
was
job.
not that
Show me
prompt.
y
I
equals
had to
x.
think.
Good job. Show me y equals x. Good job. Show me y equals 10x. Good job. Show me y equals minus x. Good job. Show me y equals minus x. Good job. Show me y equals 0. Good job. Goodbye.
Okay, so yes, this is day one's project. Professional version in day two. Next Wednesday, we'll be adding more functions such as, total number of seconds taken and timeout function. If you don't show, your correct gesture within a certain seconds, and you lose points. That kind of version we are developing. Anyway, this slide shows the big picture of what we are trying to do. Today, we show 4 hand gestures to represent mathematical equations. In addition, we added, the special case that, no mathematical, no, math gestures. Using collected images, we were using Teachable machine. We trained a deep learning model and exported to the cloud. Then we gave the link of this location to this Scratch code to start to use this deep trained model. So we send unlabeled webcam image to the model. Then the model will be returning what? Yes, this model will return label and confidence. And we say this step on labeling by asking the model is called the inference step. Okay, so this is the big picture of what we are doing today. And for today's task, we need to create 6 variables, 1 list, and 2 my blocks. So this is task 10, the final day 1 project. And another my block. And at the end, make sure to save your file, because this is something you may use for the future. Okay, so I'll demonstrate to do this. Okay, so what I'll do would be, I need to speed up slightly because we don't have enough time. So I'll first resize the screen because that's too big. Then what I'll do would be, I will define, because the program is kind of large, I would like to have 2 my blocks. So the first my block would be initialization. So initialize, okay, initialize is here. So in this my block, I would like to do something like this, turning on, making transparency to 0, wait until the machine learning is corrected, the model is ready, then I'll add something like you have 5 seconds for each question. We are not developing the timeout function today, but yeah, I want you to add that message. Then what we need to do is we need to create a list that contains all the mathematical equations. So click on variables, make a list. I'll name that as math list. All right. Then, so what we need to do is we have to delete all of the math list to clean up, to initialize the list. Then we need to add 4 functions. So instead of typing, we'll be using exactly the same name stored in the cloud model, which is in this reporter block. So add 0 to the math list, duplicate. The next function would be x, duplicate 2 together, then...
The model is ready. You have seconds for each question.
Oh, I clicked the wrong button. Okay, then the third one would be...
The model is ready.
Okay,
You have seconds for each question.
okay, I disconnected. Okay, then I will add the third function -x, the fourth function 10x, right? After adding that, we need to introduce, to make the program simpler, I would like to add another one here to set number of questions. The number of questions is proportional to the size of math list. So what I would do would be, I'll be introducing a new variable, number of questions, n questions. Then set n questions as the size of the math list, the length of the math list. So here, but I would like to make it, this number 4 to increase the number of questions proportionally. So I would introduce multiplication operator, and I'll be using first, I'll multiply by 2. That means there are 4 equations, and number of questions to ask to the user would be 4 by 2, 8. So n questions will be 8 in this case. Then I'll repeat 8 times. Instead of using 8, I'll be using n questions, so that I can just change this number to decrease and increase number of questions. So n questions here. So we'll be repeating n questions. But we need to select one function at random. How can you do that? Yes, we learned about how to use the random function. So to simplify and make the code more visible, I would like to create a variable called I, which means index. So set index as a number chosen at random from 1 to not 10. We have only 4 equations. So go down, find the length of math list. Okay, so if you see here, I can be either 1, 2, 3, 4, because the length of math list is 4. So I is the index to get one function, and actually we need to get the actual equation name. To do that, what I'll do would be I'll create another variable. So I'll create target equation. Create target equation. Say okay. So I'll set target equation, not there, target equation just created as the item chosen indexed by this I. To do that, we go to the list item here. Item I of math list. If I is 1, it will be 0. If I is 2, it will be x. If I is 4, it will be 10x. So we need this I here. Then I will ask the user text speech, show me, okay, so show me the target equation. So we have to combine two things together. So to do that, we need join operator. So show me y equal to variable target equation. Okay, so let's just test this first. Okay, I don't hear anything, so let me see whether this was working. Yeah, I have some connection issues. So, okay, let me see. Okay, let's see. All right, so something, we are supposed to hear the model is ready. You have 5 seconds for you must hear the add-on, but we don't hear. That means the cloud connection to the model has some problems. So if this happens, what I would do would be I'll save to my computer, and I'll go to Scratch and click on UN. Then I'll save this as MathDance 1. And perhaps I'll be restarting. Okay, let me double check about this, whether it has the correct connection. Okay. Oh, first I made a mistake. We should call this initialize first. So I need to call initialize first. I didn't make this initialize. Okay, let's test this first.
The model is ready. You have 5 seconds for each question. Show me y equals 10x. Show me y equals x. Show me y equals minus x. Show me y equals 0. Show me y equals 10x. Show me y equals 10x. Show me y equals minus x. Show me y equals minus x.
Yes, this program was asking 8 questions. So again, yes, the problem was I created my block, but I didn't use it. So that was the problem. So initialize, don't forget. All right, also you have something to clean up. Actually, this stage shows all the variables and lists. We may not need that. We will be displaying only essential ones. So click on this, then uncheck math list, and like uncheck target equation, number of questions, uncheck index I. So it shows only label and confidence. All right,
CJ,
now, yes.
sorry, just to jump in, just to let you know, you have 15 minutes left.
Thank you.
Thank you.
All right, now yes, we can finish this code. So after asking that, the next step is to actually send our current webcam image to the cloud model to get label and the confidence of that image frame. Okay, so to do that, yeah, let's create another my block. So here, click on this pink my blocks, make a block, and let's name that block as inference and check whether the image, the current image is the target image or not. So to do that, yes, we need some additional things to do. Okay, let's first create a variable called label. Actually, we already created the label. Also, we have confidence, but we have another variable to check whether the current image is the target image or not. So let's make a variable called TG, target recognized or not. All right. So in the inference and check block, we start to initialize the label as nothing, null, because in the beginning it should be, because we didn't send anything, that means the label value should be null, nothing. Then duplicate confidence, we did not send anything, so confidence should be 0. Then in the beginning, we do not recognize any target shape, so target recognize is null. So you can say no or false, but I prefer no. It's more natural language. Then, we need to reuse this one, and you don't need it forever. And we need to be here. So set label and recognize the current image, and return the label can be stored into label. Send the current web image frame to the model. It will return back with the confidence number, and the number will be stored in confidence, and it will be shown on the stage. Then we need one last one at the end of this inference and check to check whether the label is the target label. So we need here one if block, and we did similar one before. So we need logical AND. So logical AND is here, logical AND. Then we need to check whether the current label is variable. Current label is the target label. I mean, the target question, target equation. And we need to also check the confidence, whether the confidence is high or not. To do that, we need greater than. So confidence under variables, confidence, and I recommend to use around 75. If no confidence is greater than 75, it must be the the shape, the hand gesture for the target equation. Then if this is true, then we need to change the target recognized as yes, currently no. So what we need to do is that target recognized to yes. By the way, in Scratch, it's not case sensitive, so you can use capital Y. That's true too. That's okay too. Okay, we completed inference and check block. Now we need to use it. So how do you use it? So what we need to do, it would be after asking to show me y equal to the target equation, you need to send the first webcam image to check, to inference and check. So what we need to do is we need to call. We need to use it here to handle the first image. If the first image is not the target equation, then you need to keep sending the current image repeatedly. So we need this repeat until, and we need to keep inferencing and checking. But this should be terminated when the target recognized becomes true or yes. So we need an operator to check variable target recognized is yes. And we don't need to show that on the stage. Okay, so to handle the first image, check. If not, check again repeatedly until it recognizes the target pose. If target pose is recognized, end of this repeat until, then you need to congratulate. So text to speech, speak, good job. Okay, then so it will repeat 8 times, number of questions. You have to repeat this 8 times after the 8 questions. You need to say something. Goodbye. Okay, so this is the code for day 1 that has 2 my blocks, and this is the main code. Okay, let's test.
The model is ready. You have 5 seconds for each question. Show me y equals 0. Good job. Show me y equals 10x. Good job. Show me y equals 10x. Good job. Show me y equals x. Good job. Show me y equals 10x.
Oh, 10x.
Good job. Show me y equals x.
X.
Good job. Show me y equals 0.
0.
Good job. Show me y equals minus x.
Minus x.
Good job. Goodbye.
Okay, yeah, I passed all the 8 questions. Okay, so this is day 1's program, but on next Wednesday, we will improve this code to add timeout function as well as the way to count 5 seconds. If the user does not show the correct pose in 5 seconds, then the next question will be asked. And yes, question?
No, that's me, CJ. So on behalf of the ITU, we would like to thank you and you and your colleagues, as well of all the participants for engaging in today's workshop. And thanks to you again for such an inspiring and engaging event. We are looking forward, as CJ mentioned, to meeting you again for a second workshop, for the second part of the workshop, on Wednesday next week at the same time at 3 p.m. Geneva time. So I would now like to give the floor back to Anna for the closing information. Thank you very much.
Thank you so much. I have some additional slides to share. So can I share right now?
Yes.
Okay, I think you see my slide. I'd like to thank my assistant, Dr. Zhu, Julius Ager, and Gregory Yegian. And I have license information. Okay, the slide is for everyone. Everyone can use to share, adapt, and use for any purpose, even commercially too, as long as they give appropriate credit to the original creator. And I'll briefly introduce about the agenda on day 2. So we will review machine learning and teachable machine, and we will introduce advanced scratch coding, including broadcast, and we will improve the current app by 2 separate programs. After that, we will be introduced more mathematical functions, and we will talk about how to animate them. Then also I'll talk about different machine learning, deep learning models called POS models. Then we will wrap up. So for day 2, since we are reviewing from everything from the beginning, I think someone who didn't attend day 1 can also attend day 2. And yes, so it will be on Wednesday 25th, same time. And I'd like to thank everyone. Thank UNITU AI for good, and I thank my assistant. And I believe we have 1 or 2 minutes to talk in networking.
Exactly. So we can connect now briefly in the neural network for brief networking sessions. So for the participants who are still with us, we can connect after Anna's closing information. And thank you again, CJ, all your assistants and professors who have been made the organization of this first workshop possible. Thank you very much.
Thank you, Guilherme. Thank you, Julian.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
you.